For this PowerPoint, I got it from this website. So it is owned by Pearson Prentice, and I edited some and added some items. So these are the objectives. We will describe the distribution of the sample mean, samples from normal populations, and on the latter part, what if the population is not normal? And then lastly, we will find the probability of the sample mean. So this is just a review of what we had last time. So this is the first description of the sampling distribution of the sample mean. If the random variable x is normal, definitely the sampling distribution will also be normal. The second and third description, that the mean of the sample means of the sampling distribution is equal to the population mean, and the standard error of the mean is given by our formula here, the standard deviation of the population divided by the square root of the sample size, or the number of random samples. Let's have this item. The IQ scores are approximately normally distributed with mean 100 and standard deviation of 15. What is the probability that we obtain an IQ of at least 105? So first, we will convert 105 to its equivalent z-score, and that is 0.33. Using our table, the probability that an IQ of at least 105 is 0.3707. Let's have another item. I want you to identify how is the next item different from the previous one. The figures are similar. So based on the structure of the question, first difference is there is a simple random sample of 10 people. Another difference is we are asked to find the probability of a sample mean now. So how do we compute this one? We will convert our formula, our z-score formula, to this one. At first, we have the random variable x. We will use sample mean. The population mean here, we have the mean of the sample means, and the standard deviation is now the standard error of the mean. So the formulas are similar. Let's go back to the example. Before we proceed, let's describe the sampling distribution first. IQ scores are approximately normally distributed. Therefore, the sampling distribution is approximately normally distributed also. The population mean is 100. Therefore, the mean of the sample means is also 100. And the standard deviation of 15. Therefore, the standard error of the mean is 15 divided by the square root of our sample size, which is 10. Let's find the z-score by substituting these values. The z-score of 105 is 1.05, and the probability of obtaining a sample mean of at least 105 is 0.1469. Let's have another example. So it will measure your understanding. The mean of the sampling distribution of the sample mean is letter B, equals the mean of the population. Next example. If x is a normal random variable, the sampling distribution of the sample mean Correct. It's letter C. Has a shape that is normal. For your practice, when you're asked to describe the sampling distribution, you have to write if the distribution is normal, what is the mean of the sample means, and what is the standard error of the mean. Then substitute those values to answer letter B. Let's have the next objective. What if the distribution is not normal? From our previous PowerPoint, you can check and explore the Central Limit Theorem from this website. We have 2 to 3 illustrations here for you to understand the Central Limit Theorem. Let's have this example first. Rolling a fair die, we have the following probability distribution and its histogram. Notice, when we say normal distribution, the histogram is similar to a bell shape. This is not a bell-shaped figure. So, if we will be doing a sampling distribution like this one, there are 200 random samples of size n equals 4. Then later, using this app, the histogram with size n equals 10 and size n equals 30 will be shown. So we have our first figure here. 200 sample means when n equals 4. So originally, we have only a rectangle figure, and this time, there's a change now in our histogram. But what if we increase the number of our sample size, which is now 10? So notice there are changes, especially in the tail part. And let's increase the sample size now to 30. With this sample size, our histogram resembles now the bell-shaped figure or the normal curve. So we have the 3 histograms. So what do you notice with our histogram? As the number of sample size here, 4, 10, 30, as the number of sample size increases, our histogram is approximately normally distributed now. So that is the Central Limit Theorem. As the number of size increases, whatever the shape of the distribution, the shape becomes approximately normally distributed. Again, the Central Limit Theorem only focuses on the shape of the distribution. Let's have an example. Take note in our example, there is a random sample size of n equals 35. So, you have to use the new formula of the z-score for the sample means. So, letter A, describe the sampling distribution of the sample mean. And letter B, the probability that the mean oil is less than 11 minutes with size n equals 35. And we have the solution here. The description, the distribution of the sample mean is approximately normally distributed. Why? Because of the Central Limit Theorem. The sample size n here is large, so it is approximately normally distributed. The mean of the sample means is equal to our population mean here, and the standard error of the mean is the standard deviation divided by the square root of the sample size. Then substituting these figures to our new formula, Z is negative 0.74, and the probability that the mean oil change time is less than 11 is 0.23. If the random variable x has a skewed right distribution, then the shape of the distribution is, take note, the sample size is 50. The answer is letter A, approximately normal because of the Central Limit Theorem. Next example, how do you compute the standard error of the mean? The standard deviation is 20. The sample size is 100. Therefore, the answer is letter A. So 20 divided by the square root of 100, the result is 2. For your practice, the items here are very similar to our past lessons. So make sure you know which formula to be used. You have to describe the sampling distribution and note of the keywords such as random sample and sample means. Thank you guys.